Welcome to 5-1, Writing Fractions as Decimals. Our two objectives for this video is to write fractions as terminating or repeating decimals and to compare fractions and decimals. Before we begin, let's cover two key terms on this slide. Terminating decimal, if the division ends or terminates when the remainder is a 0. So traditionally you might have seen a fraction like this, which means 1 divided by 2. You plugged it into your calculator and you got an answer like this. The reason why it's just 0.5 is that it terminated. Its remainder was 0. So that's an example of a terminating decimal. Next up is mixed number. It's the sum of a whole number and a fraction. You've seen many of them. They can be positive or negative. So we can have a -2 and 3/4. That is a mixed number where you see a whole number, the 2, added to it is the 3/4. As we see here on the next slide, the opposite of terminating is a repeating decimal, a decimal number that has a pattern that does not terminate. 2/3. 2/3, when divided, whether by long division or with your calculator, results in the answer being 0.66. And on your calculator, as you can see down here, we keep on repeating until the last digit. For some reason, it changes to a 7. This is for all those who use a calculator to find most of their answers. That is, of course, called truncated. The calculator display can only go so far, and all calculators round their last digits. Let's go back to repeating decimals. Here again, once again, we have 2/3. We've divided it, long division, and we notice that it doesn't terminate, but the 6's keep on repeating. Alright, let's deal with that 2/3. You remember 2/3 that we wrote, and this is what we got with our calculator. And you can see that we know it's repeating. In fact, we see a traditional sign here of 3 dots. That's one way of writing, saying that these 6 repeat on forever. But what we have another way of saying that is bar notation, used to indicate that the pattern repeats forever. So what we do is we find the period, which is our next definition, is the digit or digits that repeat. We notice in 2/3 the 6 is repeating, so that's the period. And we just take that period, write it out, and put a bar over it. Alright, let's look at some other repeating decimals here in this chart. We have 0.13131313. We're going to write that with the bar notation as 0.13. Why did we choose 13, not 1313? Or something to that fact? We notice that it's the period. 13 or 13 is repeating, and that's what we want to show. Here's another one, and this one has a whole number and a decimal. And notice it says 6.8 and then 555. The 3 dots mean it goes on forever. Some students think that the 8 is also repeating, but no, it's the 5. The 5 is the period, and that's where we put or place our bar notation. All right, one more time. We have 19.1724724. All right, as you notice here, we have a pattern. The pattern is 724724. It doesn't include the 1, so our period is 724, and that's what gets the bar notation. All right, this is a typical problem you might see. Write 3/8 as a decimal. You could use long division, which you see right here, or you could use a calculator, whichever method you prefer. Both of them terminate, as you can see right here and right here. And since they terminate, there's no need for rounding on the calculator. And we just write out 0.375 as our answer. We know here in the long division it ends because 0 is our remainder. Alright, here's one. It's write 3 1/2 as a decimal. And from the definition, we know that a mixed number is a whole number the sum of a whole number, and a fraction. So we can see right here that we have 3. We're going to go ahead and write 3, and we all know that 3 is a ones digit, and right after that is the decimal. Now we've got to figure out what 1/2 is. If you don't know what 1/2 is, we can put it into the calculator, we could do long division, but for right now, we found out that it's 0.5. So this is where you can see that 3.5 is the same as 3.5, which is a whole number plus a decimal. Right, next up, we have a fraction. We haven't been using negative numbers, but we can still do what we would do with negative fractions. All right, you can either take 6 divided by 11, put it into your calculator, or you can use long division. In this example, we used a little bit of a long division, and we notice that 5, 4, 5, 4 is repeating. So what we do is we determine what the period is, and the period is 5, 4. So knowing what the period is, that's going to tell us where to put the bar. Don't forget the decimal, and remember, it was negative. Let's do a little extra. Let's do an extra one. Let's try 2 divided by 15, or the fraction 2 over 15. I plug it into my calculator. I notice I got 0.133, and it started to repeat. So what am I going to do? I'm going to determine what the period is. Is it 1, 3, or is it 3, 3, 3? Well, remember, some students think that the 1 is part of the repeating process, but it is not. It's the 3. The period is 3, and that's where the bar notation is going to go. So here we go. 0.13 with the bar notation is our answer. All right, on this slide, we're going to be asked to compare two numbers. Replace the shaded circle with the inequality less than or greater than, or in case it's equal, we'll use the equal sign. So look at the two numbers, 3 over 5 and 0.75. We've been changing fractions into decimals just for something like this. So plug into our calculator, 3 divided by 5, and we got 0.6. So we want to compare that to 0.75. Alright, we can either eye it, we can line up the decimals like here, and when lining up the decimals, if there's a number place that doesn't have anything, we'll just put a 0 there, and we go from our first number place to the next one until we can decide which one's smaller or larger. In this case, we only have to go here, and we notice that 7 is larger, and so 0.75 is greater than 0.6. But just so you know, we've got to write the original problem out, and that is our answer.